Hello friends, welcome to Risingpearl.com. We are on series 7 where we're learning a great deal on quadratic equations. Friends, this is webisode number 7 and today's topic is how do we solve quadratic equations, and we are going to be looking at completing the square method. This is part 2 because we started talking about the completing the square method in webisode 6, which was the last webisode. So friends, what we have seen so far is that we can solve a quadratic equation and find the roots using either middle term factorization or completing the square method. This is something that we saw, middle term factorization, in webisode number, I think it was webisode 5. Earlier in the series we saw how to use middle term factorization to solve quadratic equations, and in the last webisode we started talking about and looking at completing the square method. How do we use that to solve quadratic equations? Now we saw earlier in the last webisode that if a quadratic equation is given in a standard form, ax squared plus bx plus c equal to 0, where a, b and c are real numbers, a not equal to 0, somehow if we can convert this as px plus q whole square minus r whole square equal to 0. So it's not important what is p, q and r. What is important to understand is that from here to here, what we have done is that we have removed the x terms and put all of them inside a whole square. So if you look at this new version or the new form of the same quadratic equation, we have put all the x terms in this whole square. So px plus q whole square, this contains this whole square contains all the x terms inside, and outside there are no x terms. So R does not contain any x terms. So if we can do this, we have seen that from our last webisode that it can be really super easy to find the roots of this quadratic equation. So how do we do that? Friends, we have also seen, so this is what is called as completing the square method. So this is what is called as completing the square method, and in the last episode we have actually looked at some examples of how we apply this method. So today we are going to find out or write the steps to make it a formal step by step process. We will write the steps and we'll take a look at some more examples. So let's do that. So the first step is we write the coefficient of, this should be x squared. We write the coefficient of x squared in terms of p squared, where p is a real number. In other words, what we are going to do is, let's write our quadratic equation here. Ax squared plus bx plus c equal to 0. This is the quadratic equation. So the coefficient of x squared is a. So what we want to do is we want to find out p, where p is such a real number whose square is equal to a. So the next step is we write the coefficient of x this time, the x term, so which is plus b for us, as 2 times p. P is the value that we got from step 1 times q. Now what is q? The value of q is such a value that 2 times p times q equals coefficient of x. So q is such a value that 2 times p times q is equal to coefficient of x. It means that 2 times p times q is equal to b. Or from here we can say that q should be equal to b by 2p. This is how we are going to find the value of q, right? The next step is we are going to add q square to our quadratic equation, and then we are going to subtract q square. We will find out why we are going to add q square, but we cannot change a quadratic equation. So if we add q square, we have to subtract q square. Then we are going to write any constant term. We have c, so this actually should be c, which is this constant term. Keep in mind that we cannot change the quadratic equation. We are transforming the equation, right? So what we finally have will be something like this. So the first term, a x squared, will be p square x square plus 2 times p times q, and we will have a x here, plus q square minus q square plus c. And what is the advantage of doing this is that if you look at the first three terms, which is this term plus this term plus this term, we can write this as px plus q whole square. That is why this plus q square is important, because if you relate this, you can see that this is actually of the form a plus b whole square, which is a square plus 2ab plus b square, right? So the first term is this whole square, then plus 2ab, right? This is the 2ab term, and this is the b square term. Now that we have written px plus q whole square, what we have successfully done is, and you still have outside, you have in this case plus c minus q square equal to 0. You still have that, but what we have done is we have successfully put both the x terms inside a whole square, px plus q whole square, and this is the main objective of the transformation of the quadratic equation, is that we can actually put all the x terms inside a whole square, which is what is called as completing the square method. And once we have this, it is much easier for us to solve it, because then we will have px plus q whole square. So this whole square is equal to, so this will go on the other side, you will have q square minus c, and then we are going to be taking the square root on both sides, and we will get a plus minus value for this, right? And the square, p square plus q whole square and the square root will cancel, so we will be ending up getting px plus q equal to plus minus square root of this value. So friends, now we have done the application of this earlier in the webisode, in the last webisode 6. So this is the first time that we wrote it in a step-by-step fashion. Now in the next few, we will take up a few more questions to actually see how we can apply this. So how about finding the square root of this, or how about finding the roots of this quadratic equation? So first thing is, we have 2 squared, so 2x squared. So coefficient of x squared is 2. So what is the number whose square is equal to 2? That will be square root 2. So we can write this as square root 2 whole square x square plus, now this is the p, right? So plus 2 times p, which is square root 2, times q, we have to find out this value, x. Now this is the middle term. Remember, this is a term for x. So the coefficient is plus 1. So we have 2 times square root 2, but this entire thing should be plus 1. So that means we have to divide this by 2 square root 2. So that 2 square root 2 divided by 2 square root 2 will be 1. So this is the q term. So that means now we have to add plus q square. So the q is now 1 by 2 square root 2, as seen here. So it will be this whole square. Now because we added this, we have to subtract this. 1 by 2 square root 2 minus 6 equal to 0. So this will be square root 2x plus 1 by 2 square root 2 whole square. It's important to understand that because you have a plus here, we got this plus. If you had minus, this would have been minus. So then this would have been minus. So square root 2x plus 1 by 2 square root 2 equal to Now, so these three terms, we have taken them into consideration. So these are the two terms which are left. So let's take them on the other side of the equality sign, on the right side. So we will have 6, minus 6 will become plus 6, plus this minus will become plus, 1 square is 1, divided by, now 2 square root 2 whole square. So 2 square root 2 whole square will be 2 square, which will be 4, times square root 2 is 2. So 2 times 4 times 2 is 8. This will be 8. In other words, so this will be 8. 6 ones are 1 8s are 8. So 6 8s are 48. Plus 1, or this will be 49 by 8. So we have square root 2x plus 1 by 2 square root 2 whole square equals to this. So taking square root on both sides, we get square root 2x plus 1 by 2 square root 2 is equal to square root of 49 divided by 8. So we are simply taking square root on both sides. So here we will have square root 2x plus 1 by 2 square root 2 equals square root of 49 by 8, or this will be equal to plus minus 7 by 2 square root 2. So why 2 square root 2? Because square root of 8, let's see if we can do it here. Square root of 8 is equal to square root of 4 times 2. So 1 2 will come out from here. So you will have 2 square root 2. So square root of 8 is 2 square root 2, which is what we have in the denominator, plus minus 8, because again, if you take the plus 7 by 2 square root 2 whole square, you will get 49 by 8. If you take minus 7 by 2 square root 2, you will get still 49 by 8. So now let's probably give ourselves a little bit more space and do this properly. So what we have here is, so let's see, so we have square root 2x plus 1 by 2 square root 2 equal to 7 by 2 square root 2 if I take the plus value, and let's try to see if we can draw a straight line just to separate the two conditions. And we have here, the other one is square root 2x plus 1 by 2 square root 2 equal to minus 7 by 2 square root 2. So if we just simply solve it, so let's say we will get square root 2 x equal to, so denominator is the same, so 2 square root 2. So you have 7 and this 1 will become minus 1, or you will get 6 by 2 square root 2. So 2 3s are 6, or we will have square root 2 equal to 3 by square root 2, or x is equal to, this square root 2 will come here, you will get 3 divided by square root 2 times square root 2, or equal to 3 by 2. So x equal to 3 by 2 is one of the roots of the quadratic equation. Now how about looking at the minus value? So here we will have square root 2x equal to, denominator is the same here, which is 2 square root 2. Now you have minus 7 and this will become minus 1. So minus 7 minus 1 will be minus 8 by 2 square root 2. 2 1s are 2, 2 4s are 8. So we have square root 2x equal to 4 divided by square root 2, or we can say x is equal to, this square root 2 comes down, so we get 4 by square root 2 times square root 2, or x is equal to 4 by 2. So 2 1s are 2, 2 2s are 4. So this is actually, this should be negative. I think we lost the negative sign. So minus 8. So this should be minus 4. This is minus 4. And this is minus 2. So friends, here what we have seen is, the two roots of this quadratic equation using the completing the square method is 3 by 2 and minus 2. So friends, let's see if we have time for one more example. I am trying to take more examples so you can see this as to how we can apply the completing the square technique. So now let's say our question is finding the roots for 6x squared minus 7x minus 3. How do we do this? Now I'm not actually going to be doing square root 6 whole square for the first term. We'll try something different. So what we are going to do is we are going to try to make the 6 a whole square number. That means, how about if you multiply both sides of this equality, the equation, by 6? The reason we are trying to do that is because we are trying to make this term a whole square of a real number. So we can do square root 6 whole square. This is actually how we solved the last question, right? We actually had to, and we made it square root 2 whole square. But this time we are going to multiply both sides by 6. I'm just giving you one other way of solving these questions. So we are going to be using again the completing the square method. So if you multiply both sides by 6, what we will get is we will get 36 x squared minus 7 6 are 42, 42x minus 3 6 are 18 equal to 0 times 6. We are multiplying both sides by 6, so we get 0. The reason we multiplied that by both sides by 6 is because now we can write this as 6 squared x squared minus 2 times 6 we have here. Now we have to find out our q, and this times x. Now this value must be something that all of this together should be 42. So if we divide by 2, so 2 and 2 will cancel out, and if we get 7, 6 7s are 42. So q should be this. So then we have to now add 7 by 2 whole square, and because we added this we have to subtract this 7 by 2 whole square and minus 18, right? Minus 18. So this is equal to 0. So or from here what we get is we get 6x minus 7 by 2 whole square. So again friends, we have moved all the x terms inside a whole square, completing the square technique. So we have moved all of the x terms inside a whole square. 6x minus 7 by 2 whole square. Now what do we have here? So we have some minus terms. Let's get them to the other side of the equation, on the other side of the equality sign. So they will become plus. So we will have 7 by 2 whole square, which will be 7 square is 49 and 2 square is 4, plus minus 18 will become plus 18. So because it is 18 by 1, so if we take LCM 4, so we will have 49 plus 1 4s are 4, 18 4s are 72. So if you were to add this, so let's add 49 and 72. So if you add them, 9 plus 1 11, 1, so 4 7 11 plus 1 12, so 1 to 1. So we get 121 by 4. So now we have 6x minus 7 by 2, this whole square is equal to 121 by 4. So now taking square root on both sides, if we take square root on both sides, what we will get is, so on left hand side we will end up getting 6x minus 7 by 2. We will get 6x minus 7 by 2, and on the right side we will get plus minus 11 by 2. Because the reason again plus minus is whenever you do a square root you will get a plus minus value. We have seen this for last a few webisodes. Now 11 square is 121 and 2 square is 4. So we have 6x minus 7 by 2 equal to plus minus 11 by 2. So if we can give us a little bit more space here, so we have 6x minus 7 by 2 equal to 11 by 2, and let's try to give ourselves space, and the other one is 6x minus 7 by 2 is equal to minus 11 by 2. Right? So let's just make sure that that is exactly what we have. So we have, yeah, 6x minus 7 by 2 equal to plus minus 11 by 2. So we have 6x minus 7 by 2 equal to plus 11 by 2 and minus 11 by 2. Now just simply solving for x, let's see what we get. So we get here, we will have 6x equal to 2, same LCM. So it will be 11 minus 7 by 2 will become plus 7, or 11 plus 7 is 11 plus 7 is 18 by 2, or 6x is equal to 2 9s are 18, this will be 9, or x is equal to 9 by 6. Now 3 3s are 9 and 3 2s are 6, or 3 by 2. So x equal to 3 by 2 is one of the roots of our quadratic equation. Now how about this side? So here what we have is, or we will have 6x equal to, so again LCM is 2, so minus 11 plus 7, this minus will become plus. So here what you have is minus 11 plus 7 is minus 4 by 2, or what we get is 6x is equal to, now this will be 2 1s are 2, 2 2s are 4, so minus 2, or x will be equal to minus 2 by 6, or 2 1s are 2, 2 3s are 6, minus 1 by 3. So the two roots of our quadratic equation, this, using the completing the square technique, two roots are 3 by 2 and minus 1 by 3. So friends, I hope that you are getting a feel for how we can use either the middle term factorization or completing the square method to solve quadratic equations.